thing out of my way here. Start looking at some of these problems. Number 3. Are those congruent, and why? Which postulate?
They're congruent, well, because of the angle side congruence postulate.
Okay, good. How about number 4?
Let me write this down. Those we cannot infer those are congruent because they're not obtuse.
Correct. However, it is obtuse.
Oh yeah, no, you're right.
Okay. Although they don't really say that it is. In other words, if we look at it, we can see that this angle is obtuse, this angle Z and angle L. So we know that they are congruent because of that, but it does not fit one of the postulates. This is side-side angle. In other words, it's side-side angle, and that doesn't always necessarily prove congruency. Let me draw an example.
Yeah, I know. I don't need to.
Okay. And this is side-side angle, which happens to prove congruency if it's an obtuse triangle. And we can see that this is an obtuse triangle. So we know these two triangles are congruent, but there actually is not a theorem or postulate that states that. I'm not sure why, to be honest with you. There should be. But there isn't one, as far as I know. In other words, there's no postulate that says side-side angle proves congruency as long as it's an obtuse triangle. But that's the truth. It does. How about number 5? You didn't quite get everything here. I'm assuming, okay, I can figure out what the top is. The top says that that angle is equal to that angle, and this angle is equal to that angle. So, do we have congruency on number 5?
Yes, we do.
Based on?
The reflexive property as PR is congruent to PR.
Good. PR is equal to PR.
That would be,
now what? Why does that make those two triangles congruent?
Wait, what?
Why are those two triangles congruent? In other words, you're correct. One triangle looks like this, and the second triangle looks like that.
That's because of the angle side angle postulate.
Yes, angle side angle. In other words, that angle is equal to that, and that side's equal to itself. So you have angle side angle. All right, how about number 6?
Describe the error in concluding that ABC is congruent to XYZ. Well, AAA only, well, it's obvious, AAA only shows similarity.
Correct. In other words, this triangle over here could be twice as big as this triangle.
Yeah.
And it would still have the same 3 angles. Okay. Let me pull up another one here. Which one next? The upper right or the lower left?
The upper right.
Okay.
I don't know why that happened with it.
Doesn't matter. I can rotate it easy enough. All right. How about number 7?
Okay. Which postulate or theorem can you use to prove that ABC is congruent to H JK?
Okay.
You can use the angle side.
Correct. Correct. It's not the HL. You would think it would be the HL because these are right triangles.
because you don't have a definite answer on the hypotenuse.
Yeah, exactly. They didn't tell you the hypotenuses were equal. So you have to use angle, angle, side. It doesn't look like you have any problems at all figuring out how to put those together. Some people they want to go, they're not sure which way to go. In other words, notice that if I go clockwise here, what I have is side, angle, angle. In other words, sometimes it matters whether you go clockwise or counterclockwise. You know what I'm saying?
Yep.
But I haven't seen you get confused yet, so let's do more problems, and if I see you get confused on that, we'll talk about it. But
okay, 8.
So for number 8, they tell you that, here, let me blow it up a little bit. I can do that.
Yeah. State the third congruence that is needed to prove someone wrote on my book, and I need to erase that.
All right. So what are we looking at here? We got GH is equal to MN, so that's a side.
Yep.
Angle G is equal to
angle
M. Using the AAS congruency theorem, what else do we need?
We need angle L. Angle L is congruent to angle F is congruent to angle L.
Or angle H is congruent to angle N. Either of those would work. Oh, no, you're right. By angle, angle, side, you're right. Absolutely. We have to do it this way. Yeah. We have to show that F is, because if H was congruent to N, then we would have angle, side, angle.
Yeah.
We would have a different congruence there. So
FG is congruent to LM.
Right.
G is congruent to M, just like before. ASA. So that would have to mean angle. Wait.
No, you're right. It's
that would mean angle L would have to be congruent to angle F again.
It would be angle, angle, side.
So same thing, same answers for number 8.
Well, on number 9, we're using a different postulate. We're doing angle, side, angle. So
yeah, but
what's the second?
We're doing FG equals LM, meaning angle F would have to be the third congruence, because GM is already taken and HN does not count, because then that would not be angle side angle.
All right, hold on a minute here. Okay, what we know is that's equal to that. And we know that's equal
what we know is that FG.
Ah, you're right. That's equal to that. So it was a different problem. I didn't realize the premise was different here. So we know that's equal to that. We know G is equal to M. By angle, side, angle, we would have to be angle F. You're right. L. F equals L. You're right. Absolutely. Same answer as number 8.
H L N.
How about number 10?
Line segment GH is congruent to segment MN. So what we have is,
and that's equal to that.
Yep. And then angle H.
And angle H is equal to angle N.
Yep.
So to prove congruency by side, angle, side, we're going to need GH to be equal to MN, right?
Yeah. Yes.
In other words, that has to be equal to that. Okay, good. I can see you understand these really well. Good.
Explain how you can prove that the indicated triangles are congruent using the given postulate or theorem. AFE is congruent. So AFE is congruent to DFB by angle, side. So what we have...
Is it angle, side, or is it side, angle, side?
Oh, sorry, it's side, angle, side.
Correct, because the only angle we know is this vertical angle right here. In other words, we know that AF equals FD, and we know that EF equals FB. So
I think it'd be side angle, though.
No, here, if I have two angles like this, let me draw a picture. I know that's equal to that, and that's equal to that. Well, I know that that's equal to that because they're vertical angles.
Oh, yeah.
And that makes side, angle, side. You always read it in the direction that they're the closest together. In other words, notice if I read this in the wrong direction, if I went this way, it would be side, side, angle. Comes out different. So it depends.
There's a whole number, another side and two angles.
You have to make sure you read these in the right direction. You want to read that counterclockwise.
Yeah.
So it becomes side, angle, side.
No, I get that. It's just I forgot about the vertical angle.
Okay, cool. Angle or triangle AED, this right triangle, is congruent to BDE. So we've got a picture like this. And so we need to prove that AED is equal to BD.
What is that?
On your end? It's not on mine. You have a phone?
What is it? Huh.
Okay. Let's see. We need to prove these two are congruent.
Yeah. So AED and BDE.
Now, let me get this right. EF is congruent to FB, is that correct?
Yeah.
And then AF is congruent to FD?
Yep.
Okay. So how do we know? Let's see. Let me look at this a second. We have some angles. This angle is congruent to this angle?
Yep.
All right, now we can prove congruency. Based on what?
The angle, side.
Good, because ED is equal to itself.
Yes.
ED is the same side for both of those triangles. It's the bottom side. And we know that that angle is equal to that angle is equal to that angle, so we have angle, angle, side. Okay, and finally AED is also congruent to BDC by angle, side, angle. Well, let's see, if I draw BDC here, and that's 3. And
wait,
is ED equal to DC? I can't quite tell from the picture.
give me a second. Wait. Is what?
Is these 3 hash marks on DC, are they also on ED?
Yes.
Okay, so we have one side that's the same.
Now, what we also know is that AD and BC are parallel. But then again, that doesn't mean much.
No, it doesn't help here. But we do know that BDC is a right angle. What does that tell us about BDE?
And AED is a right angle too. And by the parallel, we can also get that DBC is congruent to EAD. The two right angles must be parallel, and they act as transversals, basically.
Correct.
As corresponding angles. Right?
Yes. Yes, absolutely. In other words, let's see, the transversal is this one right here. In other words, EDA is the same, congruent to DCB. This angle right there is congruent to that angle.
Yeah.
And the side is the same as that side. And this angle is also congruent to that angle by the parallel line theorem. Oh, actually we know that that's a right angle and that's a right angle. So we have angle, side, angle. That's all we need. We don't even need to prove that angle A is equal to this angle here.
Yeah.
All right, let's go on.
Wait, yeah.
Now, are 14 through 17 referring to this picture up here?
No.
Okay, this is just two different triangles.
Know whether you can use the given information to determine whether ABC equals
Okay, I got you. I got you. Let's draw ABC and let's draw DEF.
So A is congruent to D. So, yeah.
AB is congruent to DE. And
AC is congruent to DF. Yeah.
So by what postulate are those congruent?
That would be the side angle side.
Good. Okay, let's see. Let's see if I can erase this without having to redraw everything. Not so easily. So in number 15, we got angle A and D are equal. Angle B and E are equal, and angle C and F are equal.
Okay, let me write that out.
Actually, you don't need to. Because all you need to do is look at the fact they're giving you three equal angles. Can that possibly prove congruence?
No.
Right. In other words, you notice that there's no sides in there. That's all angles. So they're just telling you that one triangle, every angle of one triangle is the same measurement as every angle of another triangle. But that does not prove congruence. Could be congruent, but doesn't have to be. Okay, you with me?
Yeah.
Let me erase some.
Okay, now B, E.
All right, so number 16, B is the same as E. C is the same as F. And AC is the same as DE.
Yes, that means congruent due to the angle side postulate.
Yeah. Boy, it sure does.
Wait. Oh, never mind.
I just don't like it. Why don't I like it? Because this is definitely angle, angle, side, and this is angle, angle, side if I go the other way. I don't think this does prove congruency.
Yep.
Yep, what?
No, I'm agreeing with you.
Yeah, but
Wait,
why? Is the question.
Wait, it
In
actually
other
might.
words, it has to be angle, angle, side going in the same direction. In other words, if I go in this direction, I get angle, angle, side. But to get angle, angle, side up here, I got to go in the other direction. And that does not
again,
congruency.
But or you could just go side, angle, angle, and there's the same thing.
Correct. If you go the same direction.
But it doesn't matter if you go the same direction and you get angle, angle, side, and side, angle, angle, they're the same thing. So yes, I think it does prove congruency.
Well, let me draw a case where I think I can prove that it's not congruent. I might be wrong, but I think I can do this. I'm going to put a measurement on here of 2, 3, 4. And over here, I'm going to put a measurement of 4, 8, 6. Now, in other words, the 4 is the smallest side of this triangle on the right, and it's the biggest side of the triangle on the left. And the triangle on the right is merely twice as big as the one on the left.
Wait. But what that means is that AC and DE are not congruent.
Correct, but these two triangles, I've got angle, angle, side, and this one is angle, angle, side. Oh, hold on. No, you're right. In other words, the two sides that would be the same would be that, and then this would be angle, side, angle, and this would be angle, angle, side. So, okay. So it doesn't matter which direction you're going. As long as you have angle, angle, side, it's correct. Still bothers me a little bit. I'd like to give that a little more thought, but we won't.
Oh, it bothers me too. Like, it doesn't seem like it should be.
No, because in other words, you want the same side, right? In other words, if you take everything off, we have angle, angle, side. What I would really like the side to be the same is this one. Whoops. In other words, if it was that one, then we'd have angle, angle, side, angle, angle, same side, right?
Yeah.
The fact that AC is equal to DE instead of DF, that's what bothers me. And I suppose I cannot draw that any different. Hold on, let me go back to my original. If this was 4 and that was 4, and this was 2 and that was 3, and this was, let's see, if that's 4, 6, 8.
But would that really make sense?
Well, I'm just trying to draw two triangles that are not congruent, but that are similar, and I've just done it.
Like,
The picture I have there now is what they've said.
Think about it.
EE is equal to AC, right?
Uh-huh.
They're both 4. But notice these two triangles are not congruent. And yet they have same angle, angle. So it's 3 angles that are the same. But it's the short side over here that's equal to the long side over here.
But, I need to explain something.
There's no way those are congruent, and yet they both say angle, angle, side.
I need to explain something to you, though. If the 4 was that long, then the 6 would be longer and go down even more. And since the angle F would have to be the same,
no,
it's hard to explain 8.
Notice that this triangle on the right is exactly twice as big as this triangle. Every side is twice as big. Correct?
Yeah. Yeah.
You have the same angles. So this one would be angle, angle, side going clockwise. And this one would be angle, angle, side going counterclockwise. And so if I use just angle, angle, side, they appear to be congruent, but clearly they are not. So it's not just a question of using angle, angle, side. You have to be going in the same direction. In other words, I've got to go, if I'm going to go clockwise on one, I got to go clockwise on the other to prove angle, angle, side. And I think this is a perfect example of it. Now, I didn't draw this triangle on the right twice as big, but I could, right?
Yeah.
And I could just make it twice as big, make the dimensions 4, 6, and 8 instead of 2, 3, and 4. And C would still be equal to F, B would still be equal to E, and this side would still be equal to this side, but they're not congruent. And this is kind of an interesting one. I've never really seen this before. I hadn't realized it before. I've been dealing with congruent triangles for 7 years, and this is the first time I've ever seen where you have to go in the same direction. You have to go clockwise or counterclockwise. It doesn't matter which, but you can't go opposite. Not for angle, angle, side. You can't have one going clockwise and the other going counterclockwise. And you know what I mean by clockwise and counterclockwise.
Yeah.
Because this one on the right, it's angle, angle, side, but only if you go counterclockwise. This one on the left is angle, angle, side, but only if you go clockwise. And so you might, it's interesting that they don't mention this. I'm glad they give you a problem like this because the answer to 16 is very illuminating. It tells you an awful lot about congruent triangles. Now, when you have side, angle, side, this cannot come up. It's always congruent when you have side, angle, side, no matter whether you go clockwise or counterclockwise. And it's always congruent if you go angle, side, angle, whether you go clockwise or counterclockwise. But when you're doing angle, angle, side, you got to make sure it's the right side, the correct side. In other words, if they told me that DF was the same as AC, then they are congruent by angle, angle, side. But not if I got to go the other direction, they're not. You agree? Can you see it?
Yeah.
If you can't, I'll redraw it to proper dimensions.
Yeah.
In other words, I'll just make this one twice as big, and you'll still see that it's angle, angle, side, but one you have to go clockwise, and the other you got to go counterclockwise. All right, let's move on. 17. Is that going to be congruent? Do I even have to draw? They're giving you 3 sides. So it's got to be congruent by side, side, side. There's no way I can have three sides equal to another triangle's three sides unless they're congruent. That's absolute. And, you know, that's probably, there's only a few absolutes. Each of these are absolutes, always congruent. This one here, you got to be a little careful with. You got to make sure that you go the same way, clockwise or counterclockwise, when you're coming up with your AAS.
Yeah.
Okay, cool. Did not know that, so it's nice. You learn something new every day. And 17, you don't even have to draw a picture and label it because I have three sides equal to three other sides. That's congruency. You don't have answers to the book on even ones, do you?
No.
Too bad. I can't wait till you talk to your teacher about number 16. Because 16 is a very unusual problem. I can't believe I have not run into it before. Maybe I just didn't see it when I ran into it before, that they're not congruent. Notice how I proved non-congruence. How did I do it? I just came up with another triangle that met all three of these conditions, but they were clearly not congruent.
I think you just proved my teacher wrong.
Well, I might have. But it's an important point in math is all you have to do to disprove something is come up with one case. If I come up with one case where all three of these are true and the two triangles are not congruent, then you can't use angle, angle, side to prove congruency.
Nope.
All right. Let's go to number 18. All right.
Wait.
Those two triangles congruent?
18. Are those two triangles congruent? We don't know that.
Correct. They've drawn it so that they're congruent, but all we really know is angle, 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 right? In other words, because that's parallel to that, we know that E is the same as B and A is the same as D, and those two vertical angles are the same, but that just is angle, angle, angle. There's nothing that tells us any sides are the same. And it doesn't have to. In other words, I can easily draw this one. And clearly, in other words, these two lines are still parallel. And that's still equal to that. And so that's equal to that. And that's equal to that. But these two triangles clearly are not congruent. So once again, if I can draw one example where they're not congruent and yet everything is the same, then they're not congruent. It's not possible to prove those two are congruent without telling us something about the side lengths. Okay? Ready to go to 19?
19. We have two sides.
Okay.
Again, but we still can't prove they're congruent.
Okay, we have side, side. We don't know anything about the angles at all. You're right. I could draw a picture where TUV would not be congruent to TWV. So all I have to do is take, how could I do that? Just a moment here. Let me look for a minute. Because it feels to me that I could not draw this in another manner where they were not congruent. Let's see. Let me give you a little tip on how to do this. Okay. So I'm going to draw that side, and I'm going to draw that side. And those are the double hash marks, and that's T. Okay, and this is U, and this is W. Now, and I know that is equal to itself. Now, is there any way for me to draw those triangles? In other words, I have to connect this point with that point. I can't extend U any.
So
I have to connect, I can do it differently. Let me show you how. Hold on. This is kind of a secret of geometry. If I draw that so that it does not bisect that angle, like that, notice now it's not bisecting. In other words, this angle is not the same as this angle now.
Yeah.
And yet, now it looks very similar to my picture. It's just slightly off. In other words, line TV is slanted down just a little bit. And these two triangles are definitely not congruent.
Yeah.
They're not telling us that this line bisects this angle. In other words, angle T is not being split. Otherwise, they would tell us that that angle is equal to that angle. And since they don't tell us that, and I can draw that in a way where that is going down more than it is horizontal. You see what I'm doing?
Yep.
And clearly those two triangles are not the same, and yet everything about them is the same as what we see in our picture. How about, okay, now, and in fact, the fact that those two, now the fact that that's the same as that would not be the case if that line was slanted. That's only going to be the case if that's, well, let's think about this for a minute. No, I don't think these hash marks, these single hash marks here,
They don't mean anything.
I don't think they mean anything either. Although it kind of feels to me like they do. They do mean something. And, well, if we look at one figure only, and I tell you that's equal to that, and that's equal to that. Don't draw those middle lines. And now, if I draw a middle line, is the top triangle congruent to the bottom triangle?
Yes.
Because of side, 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 right? Correct?
Yes.
Okay. Well, now if I draw this into that, if the top triangle was congruent to the bottom triangle, it still has to be. In other words, this is congruent to that based on side, side, side. Well, hold on a second. Based on what? Hold on a minute. This is a tough one. This is a tough.
Then again, we don't know that UV and WV are the same length.
You're right. But we do know if I, sometimes I hate this program. If I draw this line, I know that TUX is congruent to TWX, right?
Yes.
Now, notice that no matter where I connect to, anywhere along this line, I'm going to end up with two congruent triangles. TUV and TWV have to be congruent. The question is why?
Actually, you're right, because
Yeah, because I can only draw those connecting lines in one way. They both have to connect to the same point.
Yeah, and they do connect at the same point, point V.
Yeah.
They are congruent.
They are congruent. In other words, TUV is congruent to TWV. I'm just trying to figure out how. In other words, if you look at the outside triangles without those inner lines, it's clear that TUX is congruent to TWX. How do we prove that angle TVU is the same as angle TVW? Hold on, I'm sure there's a way. I'm just trying to think of it, what it is. If we know the two triangles, let's go back a step. Maybe this will help. We know these two are congruent, which means that no matter what lines I put in here, they're going to be congruent. I could make it like this, okay? And that means this triangle is going to be congruent to that triangle. It doesn't matter where I connect to that middle line. I just can't, in my mind, figure out how that makes those angles the same. That's a very clever problem.
It is.
It first looks like you cannot prove congruency, but you can definitely prove the big triangle is congruent to that one, and in my heart I know that this triangle is congruent to that one. Just not 100% sure how to prove it. No. Wow. I'm not sure I know how to prove it. Well, let's go on rather than waste more time.
Wait. Whoa.
19 is a great problem. I love it, and I'm just going to have to give it more thought.
Maybe it's something using the third angles theorem. Now, because...
Well, except we only know, we don't... here we go. I just figured it out. Before I draw the connecting line, let me erase the connecting line. Because I can prove this triangle is congruent to this triangle, that makes that the same as that, and this the same as this. In other words, congruency proves all three angles. Right?
Yes.
Now when I draw my connecting line, I have side, angle, side. That side's equal to its TV is equal to TV, and based on proving the two big triangles were congruent, I know that angle UTV has to be the same as VTW. And once I've proved those two angles are the same, now I can prove that triangle 1 is congruent to triangle 2 based on side, angle, side. So, yeah, the mistake I was making was not taking the information that the big triangle is congruent to the big triangle and proceeding and finding out that all those angles are equal. All right, 20 ought to be pretty easy. QML is congruent to LPN. Not as easy as I thought.
Yeah.
Let's draw.
We only have a side and an angle.
Yeah, exactly. And we don't have a hypotenuse.
Wait.
We do have another right angle.
Yes, we do have two right angles, meaning that segment NL and MQ are parallel.
ML and what are parallel?
NQ are parallel. MQ.
Yeah. Why do you know those are parallel?
Because the two right angles. Here, let me look up the theorem that says it. Like lines parallel, lines.
Oh, yeah. No, just the fact that this is a right angle and this is a right angle. In other words, the fact that Q and L are right angles makes them parallel.
Two lines are perpendicular to the same line and they are parallel.
Correct. So now we still have side angle.
And because of the alternating interior angles theorem, we know that angle M is congruent to angle NLM.
Good. Perfect. You're right. Exactly true.
That was pretty easy.
Well, not really, because notice you actually have to look at three different triangles. In other words, we have MQL and we have NPL, but the angle that was important was N. In other words, this triangle right here is the one that's important in figuring out the problem. Right there. In other words, when you look at those two, you know that that angle is the same as that angle because of parallel lines. That is not easy. This is a hard congruency problem right here. In fact, the last two have both been hard.
These are hard questions.
They are. And mainly what tends to be hard in geometry is when you have to view it in a way you're not really looking at it. In other words, when I look at this, I'm seeing this triangle and this triangle. And it's hard to look at it as instead of those two triangles, I've got to view this green triangle right there and make determinations about angles in this green triangle, like that angle right there, we know has to be the same as that angle right there. And which means that this angle, oh, and this is a right angle. So this angle up here has to be the same as this angle down here. And now we have angle, angle, side to prove congruency. All right. Those last two were good. Those were really good. Those were some. It's been a while since I've had tough triangle congruency problems, but these two were definitely tough. You have to use a lot of things to prove these two are congruent. You got to know about parallel lines, and you have to be able to view different triangles in the same problem. In other words, this 19, you had to actually compare the top full triangle with the bottom full triangle and prove those two were congruent before you could go any further. And similarly on 20, you have to actually examine a triangle that's not even part of the picture almost, but it is. It just doesn't look like it when you first look at it. All right, Bolton, I'm going to let you go.
Okay.
I will talk to you next Tuesday. Have a good week. All right, bye-bye.